my name is Golden Sheet 12 years of primary 6 from Chifa Primary School. So we'll have a continuation from previous lesson whereas we compare the similarities and differences between molarity and molality. So for molarity and molality, they get confused a lot, not just because that molarity and molality have similar pronunciations. And so other than that, we also have the fact that the symbols are similar, which both are M, it's just that one is capital letter M, while the other is not. So then after that, other than that, the expressions are also pretty similar. So as you can see here, we have these two fractions for the expressions. So for this part, what we have over here is the number of moles of solute for both of them, so that's a similarity. Well, for this part, you may think that the only difference is the fact that one molarity is dissolved in 1 liter of solution, while molality is dissolved in 1 kilogram of solvent. But for molarity, here there's a much larger difference than that. So molarity is basically like about a percentage, okay? On the other hand, for molality, it's about the ratio. It's something like how much it can contain. Well, over here for this one, you may be wondering, how am I supposed to specify what is a solution? Well, a solution is basically a mixture, it's just that it is homogeneous, okay? So we also had an example at that time, whereas we had to find the molarity for the certain amount of hydrogen fluoride, whereas hydrogen fluoride and water placed together, it will be hydrofluoric acid. Okay. So for this part, there are different types of acids. Some are strong and some are weaker. So we found the molarity in this method. So if you want to know more about it, you can go to previous lessons and to know more about these. Okay. Well, for this lesson, we'll be having another 2 examples. Okay. So over here, what we have is, and boom, over here we have 2 questions. So for the first example, we have. Okay, so before that, for the previous example, we're mainly just solving for the conversion between the molarity and the molality. So for this, now back to example 2. So for this example, we have a solution is prepared by dissolving 42.23 grams of ammonium chloride into enough water to make 500 milliliters of solution, and we're supposed to calculate its molarity. So as you can tell, molarity is equals to the number of moles of the solute over the volume of the solution in liters. So for this part, we mainly just have to find, for the first one is number of moles of the solute. Whereas in order to find it is basically the mass of the solute, which is 42.23 grams in this case, over, so 42.23 grams times over the molar mass of. So over here, instead of just putting solute, you can just straight up put NH4Cl. And if you're wondering what they are, you can tell that for nitrogen over here, well, for this part we have 14.01 for nitrogen, then add with 1.008 for hydrogen, but there's 4 of them, so you have to times 4. Then after that you plus has chlorine, which is 35.45, and it is equals to so as you can see, for all of these, they are all 4 significant figures, so we are also going to write it in 4 significant figure over here. So 0.7895. Whereas as you can see, the unit is basically moles, and it is 4 significant figures. Okay, alright, so now that we've gotten the number of moles, we can calculate the molarity already. Which is 0.7895 over the volume, which is 500 milliliters, or so you think. So this is actually 0.5 liters, because I've already specified before that over here her molarity is the number of moles of the solute over the solution in liters. So instead of 500 grams, it will be 0.5 liters, okay, instead of 500 milliliters. And thus we will get 1.579. And what is the unit? The unit is M. So we have already said about this before, like the symbol for it. So as you can see, this is what we get over here. Now moving on to the second part. Moving on to the next example, here we have nitric acid, HNO3, here, which is a powerful and corrosive acid. I have mentioned it before, like at the beginning, whereas I have explained about that some acids are weaker, some acids are stronger. While nitric acid are considered those very strong ones, and it's very powerful and corrosive. So now we have the question. When ordered from a chemical company, its molarity is 16 how much? So the question is, how much of the stock solution of nitric acid needs to be used to make 8 liters of 0.5 m of 0.5 m solution. So for this part over here, what we have is that, so what we are finding here, the volume that's needed for the nitric acid for this to happen. So over here for this part, what we have is that, so we are supposing if, so you know how molarity is the number of moles of the solute over the volume of the solution. Well, here we are finding the volume of it. Okay, so for this part, the first, so you may be confused about why are there 2 of this the m. Well, for the first one over here, is saying it basically represents that, and for each liter of water, so it's like for each liter of the solvent, we have 16 m of the nitric acid. Well, over here, this is what we want to have. Okay, so what we can do is that, so basically which is equals to, so as you can see for this part, what you want is this, whereas you have 8 times 0.5 m. Okay, so this is what you have because this is what you want. So for this part, whereas you're over, so as you can see, this is the number of moles of the solvent whereas we got from this, well, it divides 16 from the part above, whereas because that the 16 is the molarity. Okay, so for this part over here, when you times them together, you can easily get 0.25 liters, or you can either put 0.25 liters or 250 milliliters. So both works. So over here for this lesson, we have revised from what we learned from last lesson, and we also did 2 other examples. Okay, so that'll be all for this lesson. Last but not least, thank you for your watching.